All right, this is lesson 2.1 of our Pre-Calc 11 class. Well, unit 2 is called Polynomials. Lesson 1 is called Factoring Polynomials. In this lesson, we're going to talk about what is factoring and how are some methods for factoring polynomials. Okay, some quick vocab here. If A is equal to B times C, then we can say B is a factor of A, and we can say that C is a factor of A. Also the word quotient, because a lot of times we get confused when to use quotient and factor. If A divided by B is equal to C, that means C is a quotient of AB, or C is the quotient of A over B. Also, B would be the quotient of A over C, or A divided by C. Okay, so basically what we're saying here is, okay, if you say the whole A divided by one of the factors equals the other factor, that makes the other factor the quotient. Anyways, let's move on. So right now we're talking about polynomials, and we're talking about how to factor them. And so our first method for factoring a polynomial is to find the greatest common factor. So what we mean by that is a polynomial is made up of multiple terms that are separated by a plus or a minus sign. So, for example, in example A, we have a 5, we have a minus sign, and then a 45x to the power of 5. So there are two terms here separated by the minus sign. And so if I notice 5 and a 45 is just 9 times 5, so 5 is a factor of each term. So I can factor out the greatest common factor, which is 5. And that leaves me with a polynomial 1 minus 9x to the power of 5. Notice 5 times 1 is 5, 5 times 9 is 45. So if you multiply this back out, we get back to the starting polynomial. Example B, we can factor out a 3. 3 is the greatest common factor between 30 and 9, but they also have an x in common, x squared and x. So we can factor out a 3x. 3x is our greatest common factor, leaving us with 10x plus 3. Similarly for C, our greatest common factor is 10x. They all can be divided by 10, and they can all be divided by x. And then example D, there's two ways you can write the answer. Delta math will take either way. We could factor out just a 2 and 3x's, leaving us with negative 5x squared plus 2. Now, the reason why this is not Mr. Jansen's favorite way is because that was the way he was trained as a kid. There it is. But standard convention is to make the leading coefficient a positive. So the little child in me wants to pull out a negative as well in order to make it a positive 5 out front. Of course, that makes the plus 2 a negative 2. So I would say the greatest common factor is negative 2x to the power of 3. If you put the second answer, totally fine. I have no issue with that. All right, example E, they have 3 y's in common each term. So we're going to factor out y to the power of 3. The next one, we have x and a y as a common factor. xy is the entire term, so when we factor out xy from xy, we have to put a placeholder of 1. So that way when we multiply it back together, we get xy plus x to the power of 4, y to the power of 5. Actually, now I'm looking at this, I see x to the power of 4 here, so this 2 should be a 3, and this 3 should be a 4. So x to the power of 3, y to the power of 4. Sorry about that. Anyways, example G, x squared is our greatest common factor. And then example H, we can pull a 7 out from 7 and 28. We can pull 1x out, and we can pull 2 z's out. So there's our factored form there. Take a moment, make sure these make sense to you. Again, this should be a 3, not a 2, and this 3 should be a 4. All right, so before we talked about radicals, and I gave you a geometric representation to start with. We're going to try to pull a geometric representation for polynomials, and I'm going to show you how this is the area of a rectangle. So if you think of each term as a box, For example, an x squared is a square that's x by x. 5 x's means we have 5 rectangles, each with an area of x that have a width of 1 and a height of x. So the height is equal to the width of the square. 1 times x is just x, the area is x. And then plus 6 means we have 6 squares, each with an area of 1, meaning their side lengths are 1 by 1. So the side length of these red squares is equal to the width of the green squares, and the height of the green squares is equal to the side length of the blue squares. Now, when I say factor, remember factoring is a number times a number. That's our formula for the area of a rectangle. So if I can take these tiles and make a rectangle out of them, I can look at how long the top is, how long the side is. Those would be my factors. So we're going to take those tiles. Oh, that's fun. Okay. I could take these tiles and I move them all together, and I've made a rectangle. Now the rectangle across the top is the length of x plus the length of 1 plus the length of 1 plus the length of 1. This side is the length of x plus the length of 1 plus the length of 1. Or the top is x plus 3 and the side is x plus 2. So that means that if we take our polynomial x squared plus 5x plus 6 and we think of it as the area of a rectangle, the width would be x plus 2 and the height, or the width would be x plus 3. So when we factor this thing, it's x plus 3 times x plus 2. Okay, and we can check that too, right? We can take these binomials, we can multiply them together, use box method, and we can get back to the original equation. So that should work forwards and backwards. All right, some examples here. So if I have a trinomial and I want to factor it, I'm going to use box method. When I say box method, if you've learned FOIL before, this is just FOIL backwards. First box is F-O-I-L. Anyways, so I know when I did box method for multiplying terms, we started with the factors, multiplied to get the insides, added up the insides to get the answer. So for factoring, we're going to do that same process backwards. So we're going to start with pieces inside the box. X squared goes here, 48 goes here. These two terms add up to be 14. Now we can look at all the multiples of 48 to see what options can go outside the box. One trick that you could use is what multiplies to be 48 and adds to be 14. Well, 6 times 8 is 48, but 6 plus 8 is 14. So I know 6 and 8, x, can go inside the box. And we could factor accordingly. Similarly, I can put the example B, I can put x squared in the box, I can put negative 16 in the box. I know my other two boxes have to be x terms. I'm thinking what multiplies to be negative 16, but adds to be negative 6. Well, 2 times negative 8 is negative 16, but 2 minus 8 is negative 6. So 2 and negative 8x are my boxes. And then I can find my numbers outside the box to finish my factors and write my solution. All right, a couple more examples. And we're doing the same thing here, same process. The first and the last terms start in the box, figure out our x terms, make sure they add up to 1, or may have to make sure, example D, the x terms add up to negative 8. One clue for you, one trick, is if both, in the trinomial, if we have a plus sign and a plus sign, so the middle term's got a plus and the last term's got a plus, our factored forms are both going to be plus signs. If it's like example D, we have a minus sign and then a plus sign, that means they're both going to be negative, which should make sense because we're doing a negative times a negative to get the last term, so that'll be positive. And then a negative minus something has to be a negative, so the middle term will be negative. If example C and example B, the last term's a minus sign, that means that one of the terms is a plus and one of the terms is a minus. Okay, so hopefully we have a better understanding of factoring, what it means to factor a polynomial. We could factor polynomials by pulling out our greatest common factor, and we could factor polynomials by using our box method. We're just using it in reverse from what we used in the past.